Hey folks, congratulations. You've made it to the last Solutions podcast. We're talking about Solution Stoichiometry. Oh yeah, well what does that mean? That means you can be doing a lot of math. So get out your calculator, get out your pencil, and we're going to be doing a lot of math here. Remember guys, when we're doing stoichiometry, let's just use my favorite one, which is 2H2 plus O2 gives H2O. Remember that these numbers here are our ratios of moles to moles. So everything we always have to do when we're going from moles of one thing, let's say that I have 3 moles of this, and I ask you for how many moles of oxygen is also going to be consumed. All right, we always have to go from moles of our known substance, to moles of our unknown, or our target substance. And in this case, we're going to have a 2-to-1 ratio. So we're going back to stoichiometry. So we always have to work with moles. Now, when we're talking about solutions, we're sometimes talking about molarity, we're sometimes talking about grams, all of those things. So we have to have some way of getting to our moles. And then we might want to know information on the other end, like we might want to know grams or something else. Okay? So we have to make sure that we always go to moles. All right. This podcast is only 3 problems, but there's a significant amount of work with each one. So let's go ahead and start working the first one. You have 75 milliliters of a 2-molar sodium hydroxide solution and it's reacting with magnesium chloride. How many grams of magnesium hydroxide will be produced? Well, the first thing we have to do is we have to come up with a balanced chemical equation. So we have sodium, and we have hydroxide, sodium hydroxide, and it's reacting with magnesium chloride. So that looks like a double replacement reaction to me. So we're going to get magnesium hydroxide and sodium chloride. And let's see, that means I'm going to need 2 of these, that means I'm going to need 2 of those, so I'm now balanced. And it says how many grams of magnesium hydroxide will be produced. So I want this in grams. Now my problem is I have 75 milliliters of a 0.2 molar solution of sodium hydroxide. Now I know I've got more magnesium chloride than I need, so I don't have to worry about that because it says I'm in excess. So I have to figure out how many moles of this I have. Well, how do I do that? I have molarity. Well, let's look at what molarity is. Molarity is equal to moles per liter. So if I want to solve for moles, all I have to do is multiply moles times liters. So moles is going to be my molarity times my volume, which is in liters. Right? So I should be able to do that. Well, my molarity is 0.20. That's given to me above. How many liters do I have? Well, I've got 75 milliliters, so I have to convert that to liters. So that's 0.075 liters. Right? So when I multiply that out, I get 0.015 moles of NaOH. Now I can do stoichiometry, because now I've got moles. So I'm going to start with 0.015 moles of NaOH. And now I have to convert from moles of NaOH. Here's my stoichiometry piece. Moles of sodium hydroxide to moles of magnesium hydroxide. Moles of magnesium hydroxide, that's right. And then I have to go from moles of magnesium hydroxide to grams of magnesium hydroxide. And then I'll be done. All right, well, what's my ratio of sodium hydroxide to magnesium hydroxide? Well, that's 2-to-1. That's pretty easy. And moles of magnesium hydroxide to grams, I have to calculate how much magnesium hydroxide weighs. So if I pause for a minute and figure that out, that will be 58.316 grams per mole. So 58.316 grams per mole. If I go and multiply all that out, I end up with 0.44 grams of magnesium hydroxide. All right, That seems pretty simple, not terribly complex. Let's see if you can do one. Right. So go ahead and pause the video, see if you can figure this one out. All right, well, let's come up with a balanced chemical equation. We have hydrochloric acid, which is HCl, and it's reacting with zinc, and it's producing, obviously that's a single replacement reaction, that's zinc chloride plus hydrogen gas. That means I needed 2 there to balance it. All right, did you get that far? All right, now we're trying to figure out the volume of hydrogen gas. All right, the volume, that's going to be in liters. And it's because it's an SDP, that's going to be that 22.4 business, 22.4 liters in 1 mole. And I know I'm starting with 3.81 grams of zinc, and I'm starting with, oh gosh, you know, we're going to have to do a limiting reactant problem. So now that I've told you that, can you do it on your own? Again, try and pause the video, see how much of this you can get through on your own. All right, well, let's see. We learned how to do this earlier, that our moles is equal to our molarity times our liters. So that's going to be 0.20 molar, and it's going to be times liters, which is 0.0532 liters. So my moles of hydrochloric acid, when I do that, are going to be 0.01064 moles of HCl. Now guys, I realize I'm keeping more sig figs than I'm allowed to, but I want to do that. I only want to round once at the end. Alright, so that's moles of HCl. So let's go ahead and work through that one. That's 0.01064 moles of HCl. And I have to use stoichiometry to get rid of moles of HCl and go to moles of hydrogen, because that's what we're trying to figure out. And we're trying to go from moles of hydrogen, we want to go to liters. So that's 22.4 liters in 1 mole. And my moles of HCl are 2, and my moles of hydrogen are 1. Right? So I multiply that out, and I get 0.12 liters of H2. Now, we're not done, because we still have to do exactly the same thing for zinc. So, but zinc, we only need to do a stoichiometry problem because it's a solid. So we have 3.81 grams of zinc. And that means we have to divide by the molar mass of zinc, which we can look up on the periodic table, and that's 65.39 grams of zinc in 1 mole of zinc. And now we have to convert from moles of zinc, done this many times, to moles of H2, and then from moles of H2 we have to go to liters of H2. So moles of zinc is 1, moles of H2 is 1, and in every mole of H2 that's going to take up 22.4 liters. When I multiply that out, I get 1.3 liters of H2. So clearly this is my limiting reactant, HCl is my limiting reactant, so the maximum I can produce is 0.12 liters of H2. Alright, here's your third problem. Again, pause the video, see if you can work it out. Alright, let's see, I have lead 2 nitrate, that's Pb, NO3, but NO3 has a -1 charge, lead has a 2 charge, so that's that one, plus sodium phosphate, that's Na, that's PO4 for phosphate, but phosphate has a -3 charge, sodium has a +1. So then this is a double replacement reaction, so it's going to be Na, NO3, plus Pb, PO4. Ooh, that's a +2 and a -3, so I have to do that. Alright, now I have to balance. And let's see, I have 3 leads, so I'll put a 3 over here. That means I have 6 nitrates, so that means I have to put a 6 there. That means I have 6 sodiums, and that means hopefully I've got 2 phosphates, and I do have 2 phosphates, so I'm all balanced. Alright, it's asking me how many grams of precipitate are formed. So you have to go back and look at your solubility table, and what you'll find out is that all three things, the first three things are all aqueous, and your lead phosphate is going to be your solid. So that's the one it's asking about, is your lead phosphate. So let's see, we're starting with 150 mils of this and 50 mils of that, so we're going to have to go and do two solution equations. So my moles are equal to my molarity times my liters, which is going to be 0.30 times 0.150, and that's going to give me 0.045 moles, and that's this one up here. Let's try my other one, which is 0.055, which is my liters, and it's 0.6. I'm multiplying it by, and so this one is going to be 0.033 moles. Now, clearly that doesn't tell me which one is limiting, because I still have to go through all my stoichiometry piece. Alright, so one thing I do have to figure out is how many grams of precipitate are formed. So this is my precipitate, so I have to figure out how much that weighs. Right? And I'm not going to waste your time doing that. You can do that. But that's 811.5 grams per mole. Alright, so let's do my stoichiometry piece. I start out with 0.045 moles of lead nitrate. And I have to get rid of moles of lead nitrate, moles of PbNO32, and go to moles of my target. My target is over here, so that's my lead phosphate. Am I done? Nope, I have to go to grams, so I have to go from moles of Pb3, PO42, to grams of Pb3, PO42. Okay, well I can see that that's 811 grams, 811.5 grams in a mole, and my relationship between lead nitrate and lead phosphate is 3 to 1. So I put a 3 there and a 1 there, and I multiply this out, and I get 12 grams. And let's see what we have here. We start with 0.33 moles, 0.033 moles of sodium phosphate, and I have to go through the same process of going from moles of sodium phosphate to moles of Pb of lead nitrate. Everything from here on out is going to be exactly the same as up above. So I have moles of Pb3, PO42, and grams of Pb3, PO42. I told you it's the same as above, so it's 811.5 and 1. And we have a relationship here of 2 to 1. So we put a 2 at the bottom and a 1 on top, multiply this thing out, and we come up with 13 grams. So this one's limiting. So our lead nitrate's limiting, so the number of grams we can come up with is 12 grams. We can never make 13. Alright, so those are some examples of solution stoichiometry. Simply the piece that you're adding is right here to figure out how many moles of your substance you have. Okay, that's the only part that's different. Everything else remains the same of stuff you've done before. Okay, that's it for solutions. Go practice, and we'll see you in class. Ask us if you have questions. Have a great day. Bye-bye.